So in the next video, in the last video, I was trying to do this question and I didn't know what I was. So I'll show you what it was. We were trying to find the force on JK of a 5 centimeter piece. And reading through here, there was 50 turns, so N equals 50. Permanent magnet provides a field of 0.3, so I put B as 0.3. And 5 centimeters, so 5 times 10 to the negative 2. But we didn't know I, so we couldn't figure out the force. But now, they say, figure out the force, and they tell us the current. Calculate the magnitude of the force. So all we need to do is F equals NILB. And this time we have N was 50, I is 6. This is 5 times 10 to the negative 2. And that's 0.3. So if my calculator works this time, I just need to figure out how to use it. I don't know what I did, but hopefully that'll work. Now I can do some of these. Sorry, the camera's playing up a bit. We get 50 times 6 times 5 times 10 to the power of negative 2 times 0.3. And that gives us 4.5 newtons. Okay. That was 2011, question 5. Know how to use your calculator, students. Okay, so this is 2006, and we're going to be doing question 2 and question 3. And this is all force NILB. Oh, and also direction. So I like using the right-hand side rule. So what's happening here? Diagram, we're used to this, we're going to know there's current going through, he's a solenoid. Okay, now what? So this solenoid has a magnetic field strength of 2 times 10 to the negative 2 T. A U-shaped conducting wire, ABCD, carrying a current of 5 in the direction of A to D. It's placed, highlights everything. It's 6 centimeters by 2 centimeters, it's completely immersed. Okay, so we need to figure out the direction. What is the force magnitude on the 6 centimeter wire of CD in figure 2A? So we're looking at CD from here to here. Okay, so first we need to figure out the direction of this field. Because remember, to have a force, it's a relation of current and field. Okay, so what have we got here? Well, we know the current, but we don't know what the field is. So we need to figure out how to make the field from this. So remember, this is a positive end, this is the negative end. Now we do our right-hand rule, and we go around. So as my thumb is coming down, I'm imagining my thumb coming down here, doing the right-hand rule, and I'm putting my fingers out. I realize on the outside, the field is pointing to the left. Okay? But now if I try on the inside, my fingers are pointing to the right. So we should be able to check that by going back up on this side, on this dotted side over here, and putting my thumb along that current, still going in this direction. In this direction. On the inside, you see how my thumb would be on the furthest away, so my fingers will be inside the coil. It's pointing to the right, just like before. And on the outside, my fingers are pointing up. On the outside, my fingers are pointing to the left. So on the outside, the field will be going to the left. So inside this coil, we know the field is going to the right. So, next, we need to put our thumb in the direction of CD, because that's the direction of the current. And now, our field is in the same direction of our thumb. So remember, for this to work, these have to be perpendicular. Right-hand slap rule. Our thumb is in this direction, our field is going perpendicular. If they're in the same direction, we get 0 force and we get no direction. And that's what's happening with CD, because CD is in the same direction as our magnetic field. Okay, Now we can try it on BC. BC works a bit better. We have current flowing this direction from positive to negative, so our current is flowing this direction. Now, our our field is going that way, so our force is going up. So the direction would be in Q. I'm going to go up or Q, because I'll try and take it out. The current is going this way, field is going that way. Do it with your own hand, and you will see the truth of what I am saying. Now we need to figure out the magnitude, so we just go F equals NILB. There are no coils, no turns, so there's no turns. Current is 5 amps. Length is 2 centimeters, so 2 times 10 to the negative 2. Remember to compare back to meters. And field is 2 times 10 to the negative 2. So this one I'm going to do in my head. And you get 10 times 10 to the negative 2. So I'm just multiplying these together. So that becomes 10 to the negative 1 times 2 times 10 to the negative 2. So that is 2 times 10 to the negative 3. So 2 times 10 to the negative 3. Or if you wanted to understand that, if this was 2, 2 times 10 to the negative 1 would be 0.2. So this would be 10 to the negative 2. This is 2 to the negative 3. Or we start here and we go 1, 1, 2, 3. That's why we put the 2. So that's how you do force equals NILB and the right hand slap rule. I have one more set of questions to do, and then I'll let you go home out and play or do whatever you guys like.